All right, so now that we have an Arduino program that accepting and returning serial values, and we have a Python program that can connect to the Arduino, let's get them talking back and forth more consistently and displaying that data on our graph. Now we're using wxPython, so in our init function for the bottom panel, let's declare a timer. So I'm just going to call it self.timer is equal to wx.timer argument of self. So what a timer does is in wxPython, because it's a GUI type application, if you want to run something over and over and you put it in a for loop or a while loop, but you're trying to update the actual panel, your panel will go non-responsive. So the timer does stuff on different threads or whatever, and it allows the front panel to update every time through an iteration. And now we're gonna have we created the timer. Now we have to bind the timer. So self dot bind wx dot event timer. The next argument is going to be the function the timer calls. So we're just let's self dot time interval. We haven't made this yet, and then the actual timer. So self dot timer. So we create the timer here. We bind the timer to this function time interval. I'm gonna make time interval over here just because I'm going to be using this on start click. So define def time interval, and it's going to take self and it's going to take event. And then let's right now, to make sure it's working, just print out a variable. So let's do this. Let's declare self dot timer check is equal to 0. Let's print self dot timer check, and let's increment self dot timer check. Now we've created this interval, so every time the timer ticks, it's going to run this interval function right here. So we want to start the timer by self.timer .start, and it's going to take an argument of how quickly you want the timer to run. Right now, let's just do 500 because this is in milliseconds, so we want this to run every half second. And then on this one, we'll do self.timer.stop, and this takes no argument. So if we run this and we hit start, it's going to make a connection with the Arduino, print out the Arduino is ready, and now every time through this timer right here, it's going to increment the number of the timer check. If I hit stop, it should stop the timer. And if I hit start again, it should continue the timer without making a new connection to the Arduino, which is what we want. Okay, so let's get rid of this timer check because we don't really need that anymore. Our timer works. So on the timer, what we want to do is we want to, on this serial Arduino, we want to write A. We want to write the Arduino, we want to give it an A command, and we want to get back, so we're going to get back the analog value. So self.serial Arduino dot read line is whatever it is, and let's just again do this step by step. So in case there's a problem, it's easier to debug, and print out this this temp value. Let's also change. Let's just work this right now, and then we'll change how fast this is working. All right, so it's 613, 612. So this value is changing as I turn the potentiometer. So that's really good right now. You know what's going on right here? We're getting this extra new line. because of this new line command right here. That's what's going on. So if I run this again, okay, that's not what's going on. But I guess we don't need the new line. So we're printing this, we're getting this value. Now let's send this to the graph. So the graph up here is going to need to get changed a little bit. Draw is going to need to take an argument of x and y. And let's comment out this x and y. So nothing really changes here. What's going to change on top.draw, we're going to need to send it in x and y. So we'll just draw a 0, 0. And we're going to have to create an array right now. So we'll create a numpy array that's just empty for x and y. So this will be how we save our values. And this again is in this this bottom panel. We're just creating an empty array to hold the values that are coming in from the Arduino. We're just going to need, so let's stop printing this. We can still print this. And then we'll have self.y is equal to this append. And we're going to append self.y and an int of temp. So temp is right here. We're going to cast it to an integer and save it to y. Then we'll have self.x is equal to, we'll append self.x, and we'll need to make a new variable, self.x counter. And then we'll increment the counter. Should have probably just left the test I was doing, but we'll just make this new value. So self.x counter is equal to 0. So we'll start it at 0. Every time through, we'll increment it. So this will line up my x and my y. And then what we'll do is we'll call self.graph is our top panel. So self.graph .draw, and we'll send it self.x self.y. Okay, let's see how this works. Let's start. Make the connection, and we're not updating the graph. Why are we not updating the graph? Oh, up here, I'm going to have to run this self.canvas.draw function. So right there is going to be self.canvas.draw, and this should update my graph for me. All right, so there we go. We're updating this graph every half a second. And this is me twisting the potentiometer. Let's take this a step further. I don't like this, a couple of things. One, I want to make this go faster. Two, I don't like this blinking color deal. So the blinking color is easy to fix. I'm going to just, in my plot, I'm going to have plot, I'm going to plot a solid line, and I'm going to plot a 0, and I'm going to clear the axis before I plot. And now this should take care of that color. So this is going to plot it as a solid line with marker color. And so these are all my individual actual points. So there we go. We fixed that problem. Now the last problem I want to fix is I want to make this graph faster, and I want to deal with that with this send command. So there's two things I'm going to do. First thing I'm going to do is I'm going to grab the value of this start right here, and I'm going to grab the value, so it's going to be self.textbox sample time dot get value, and I want to make sure this is a unit I can use, so we'll cast this to an integer. And then finally, if I want to change this as I'm running this onSend value, what I'm going to do is I'm just going to I put the value, doesn't matter, but I'm just going to start the timer again. I'm going to say self.timer.start int of value. So the value right here, this onSend, is the value of the sample time, and I want to just restart the timer. So let's start it at 1 second. That's not going to do anything. That was stupid. Should probably put a check on that so I can't send it. I should really comment it, block it out until start is pressed. But when start's pressed, I'm going every second. Let's change it to 500. Hit send. It will go faster. Let's go to 100. Hit send. Oh, it looks pretty good right now. This is going a lot faster. There's still a little bit of lag. I can feel it. But it's much more in real time than it was before. Let's see how fast this can go. 1. There it goes. And that feels really, really good right now. There doesn't seem to be really any lag or noticeable lag when I'm twisting my potentiometer. So if I stop it, it will stop. And I want to say, hey, maybe let's zoom in from 320 to 420. Set the y-axis. I can zoom in on my points right here. Okay, now I can start again. Just starts where it's left off. And there you go. That's displaying one analog port on the WX panel. What I'd like to do is have these checkboxes control multiple inputs, so I can parse that on the Arduino side, and then I guess put another button in here to save the data, and I should block these out until the start button's pressed.